main objective of this program is to test whether a given array of values represents max heap or not. We know that max heap has to have the following property, that is, any element value should be greater than or equal to its two children values. That is, if a element index is I, its child indexes are 2 into I plus 1 and 2 into I plus 2. At those locations, whatever values are there, the ith element value should be greater than or equal to those two values. This has to be satisfied for all the values of I. That is, for all the elements of the array. Then we call that array of values represents max heap. To test, we propose the following procedure. We start from the last element and we'll traverse until the middle element, that is, middle element of the array. And then for each element, we calculate its parent index. How do we calculate the parent index of a node whose index is I? Simply I minus 1 by 2. And if this ith element value is less than or equal to its parent value, we say it is okay. However, we continue further. Now we consider its parent index value and we take its parent, that is parent's parent, and compare whether this ith element parent value is it less than or equal to its parent or not. If not, we say that the array is not in max heap form. Otherwise, we continue the same thing further till we reach the root node, till we find a node whose index is 0. This we repeat for all the elements of the array, that is, starting from last element to middle element. If this property is satisfied, then we call it as a max heap. Otherwise, it is not a max heap. The function ISITHEAP is written such that it takes an integer array and number of elements in the array as arguments, and then returns 1 if it is having the max heap property, otherwise returns 0. Now, in the following slides, we'll try to simulate how this function works with the help of the following data. Rather, I say array having the data. That is, data is 98, 67, 58, 28, 36, 40, 48 and 10. Now, next slides will simulate this function. The last element index is 7. That is, 7th element we will take. Its parent value, that is j minus 1 by 2. That is 7 minus 1 by 2, that is 3. A of j, that is 10. A of k, that is 28. Is 10 less than or equal to 28? Yes. Thus, the while loop, inner while loop will be continued. We understood 10 is less than 28. Now we want to test whether 28, that is, parent of 10, is it having the max heap property compared to its parent or not? That is the reason why we continue the while loop. So now we take j value as 3. Now its parent value, that is j minus 1 by 2, that becomes 1. A of j is 28. A of k, its parent, is 67. Is 28 less than 67? Yes. Thus, till now, the maxi property is observed. Now we want to test whether 67 is it less than its parent or not. Thus, j value will be taken as k, that is j value becomes 1. Then its parent index, j minus 1 by 2, that is 0. A of j is 67, A of k is 98. Is 67 less than 98? Yes. That is maxi property is satisfying. Now we come out from the while loop as j value becomes 0. We understood that is 10 is less than its parent, that is 28. 28 it is less than its parent 67. 67 it is less than its parent 98. Now consider the second element from the last. Its index is 6. J value is 6. Its parent value j minus 1 by 2. 6 minus 1 by 2, that is 2. A of j is 48. A of k is 58. 48, is it less than 58? Yes. Thus, the while loop will be executed once. Now we are interested to check whether 58 is it less than its parent or not. Thus, j value will be taken as 2. K value, that is the parent index, that is j minus 1 by 2, is calculated as 0. A of j is 58 and A of k is 98. 58, is it less than 98? Yes. Thus, we'll go to the while loop. Now, we'll come out from the while loop as j value becomes 0. We found that 48, its parent is 58. It is less than, 48 is less than 58. Now further we understood that 58 is less than its parent 98. Now I value becomes 5, that is fifth element we have to take, that is 40 we have to take. So thus j value becomes 5. 5 minus 1 by 2, k value becomes 2. A of j 40, A of k 58. Is 40, is it less than its parent 58? Yes. Thus, while loop is going to get executed once more. J will be taken as 2. Its parent value, j minus 1 by 2, taken as 0. A of j 58, A of k 98. 58, is it less than 98 its parent? Yes. Thus, while loop will be executed again. J value becomes 0. Thus, will come out from the while loop. By now, we understood that 40, it is less than its parent 58. 58, it is less than its parent 98. Now, I value becomes 4. That is fourth element. That is 36. K value becomes 4 minus 1 by 2. That is 1. A of j 36. A of k 67. 36 less than 67? Yes. Thus, the while loop is going to get executed once more. J value becomes 1. K value becomes 0. A of j 67. A of k 98. 67 less than 98? Yes. While loop is going to get executed once more. Now we'll come out from the while loop and we found that in now that all the elements starting from the last element to middle element we have tested, and that maxi property is seen for all the elements, their parents and their parents also the property is seen. Thus we can say this set of values represents max heap. that the function returns 1. Now let us consider another set of data. And if we take the last element 10, just like previous demonstration, 10 it will be less than its parent 28, and the 28 it is less than its parent 67, 67 it is less than its parent 98. Thus we go to the next element. Now if we take the element 48, its parent is 8. Is 48 less than 8? No. That is, the max heap relationship is now not satisfying. Thus this data can be set as not in max heap form. So the function returns 0.